Welcome to queenon7.com. Please share and like my videos. Today we're going to learn about the second part of the aldehyde and ketone reactions. We will look at how a nucleophilic addition is going to happen on the carbonyl carbon in the aldehyde and ketones. Now, you do remember the carbonyls where you do have a COO bond. So if I take an example of an aldehyde, in this reaction, we're going to look at how actually HCN or NaCN or KCN can be used to do the nucleophilic addition. Now, for this reaction, if we have HCN, KCN or NaCN, so potassium cyanide or sodium cyanide or hydrogen cyanide, these are the three reagents we can use to do the nucleophilic addition. Cyanide ion, Cn negative ion, will be actually known as the attacking nucleophile. The problem is the HCN is actually a very toxic gas and is very poisonous. So though KCN and NaCN, they are also poisonous, they are also toxic, but this is actually the gas. HCN is a gas and it's very hard to actually control it. Now that's why we normally use KCN and NaCN to do the reaction. If I do that the reaction, and I'm not going to write down the overall equation, I will show you the state with the mechanism. The cyanide ion will have the lone pair electron, and it will actually provide it to the carbon. Because this is partial positive, that's why it is actually allow cyanide to come close to it. The moment this is going to happen, this carbonyl there, CH3, that will go there, and the electron pair will transfer onto the oxygen, and then the cyanide will attach as it is. And then you will have hydrogen. I purposely did not write the second condition we need to do the reaction. In the first step, the cyanide will actually attach. For the second step, you do need some sort of proton which will come close to the oxygen and make a hydroxyl group. For to do that, the second condition is you need some sort of acid which will provide you the proton. So H2SO4 or HCl, both will do the job. And that will produce a H positive ion. That H positive ion will come close to the oxygen on the which is actually produced from the carbonyl into O negative ion. That will produce CH3, OH, Cn and hydrogen. Now, to name these nitriles, Cn is actually at the part of the longest carbon chain. So that will be actually written with the parent hydrocarbon. This will be known as the side chain. Hydroxyl group will be known as a side chain. Now, if this is the case, I will write it down 1, 2, 3. We'll start the numbering from the nitrile group. Now, this group is actually C triple bond N. So this will have the priority, and you start counting the numbering from there. So if you count it there, 1, 2, 3, so it's propane. This is a side chain hydroxyl group. The position of the side chain is number 2. So 2 hydroxy, 1, 2, 3 propane, and you just put the word nitrile. Done. This is how you actually name the nitriles. Now I'm going to look at the, if I have to replace this aldehyde, and aldehyde will be reacting with the NaCN or HCN, what will happen then? I will put just a CH3 there, a propanone. Propanone is going to react with the same conditions. All you have to do is just replace that hydrogen with the CH3, and you will get this molecule at the end. So they will actually undergo nucleophilic addition, and you will see now this time you will have 1, 2, 3, because you're going to start the counting from there. 1, 2, 3 or 1, 2, 3. It will stay. The longest carbon chain will be the propane. Now, if you look at it, the hydroxyl group on the top is side chain, and this will be known as a side chain as well. So 2 hydroxy, 2 methyl, and then propane nitrile. So both will have different products, just an addition of one of the carbon atom there. Now, if you look at the second part, now when you do the A-level identification test, you can actually, before you start the differentiating between the aldehyde and ketones, what if you have carboxylic acid as well over there? So what you need to do is you need to identify whether your compound actually contains the carbonyl group or not. So what you can do to detect the carbonyl group, you can actually have the 2,4-DNP, 2,4-dinitrophenylhydrazine we can use to actually identify whether your compound has got the C double bond O group in there. So if I try to draw the 2,4-dinitrohydrazine, this is nitro group, and then you have nitro group there as well. This is benzene, and you have N and you have NH2. So this one will have NH. This is 2,4-dinitrophenylhydrazine. Now this one is when it's going to react with, for example, if I react it with an aldehyde. An aldehyde, you do know that it is partial positive and partial negative. The nitrogen, which has a lone pair of electron on top of nitrogen, it will actually provide that electron density and approach this carbon in the carbonyl group. Once you're going to do that, it will be converted into CH3, C bond O, H, and then you will have N there. The hydrogen will be written as it is, and you will have NH, and then you have NH, and you have the benzene group there, and you have NO2 and NO2 there. Now, once you have actually produced this, it's not going to stop here, so you have to do actually elimination of water, which is called dehydration. If you do remember, in the alcohols chapter, when you do the dehydration of alcohol, you produce the alkenes. So here you are going to do the dehydration. So the OH from the carbon and the hydrogen from the nearest next to this carbon atom, the nitrogen will lose the hydrogen. So that will actually take the water out. So that will produce CH3, C bond H, double bond N, bond NH, bond with the benzene ring, and you have NO2 there and NO2 there. Now this will produce an orange color, and this will be the identification of the carbonyl group present in the compound. Thank you very much.